This screencast is about how to solve equations that have parentheses and fractions in them. First thing we want to look at is the distributive property. We'll use it so frequently in this section, we want to go ahead and practice it ahead of time. Just as a reminder, the distributive property says that you need to actually distribute or multiply a number that's in front of parentheses. So here we multiply a times b and a times c. In the examples you see below, 3 will get distributed to both x and 2 to give an answer of 3x plus 6. 5 gets distributed to y and the 3 to get an answer of 5y minus 15. Notice how the minus sign carries on to the answer. In the last one, negative 6 is distributed to both the x and the 2. Negative 6x minus a negative 12. Usually what we do when we see that is just make it a positive, since negative 6 times negative 2 is positive 12. This is something that you'll have to check yourself every time when you see negatives. All right, now that we've seen some of those, let's look at equations that involve the distributive property. For this, we want to get the x by itself, but I'm going to, first of all, distribute the 3. So that on the left of the equation, I'll have 3x plus 6. Now it looks just like the equations we had before. I'm trying to think about undoing things away from x. So I'll subtract 6 first. And then divide by 3. So in this first one, x equals 17/3. In the next example, we have distributing in both the left side and the right side. I'll distribute the 4 on the left and the 2 on the right. Now we have an x on both sides. When that situation occurs, we want to try to get it on the left, if possible. So I'm going to do that by subtracting 2x from both sides. Notice how on the right-hand side, this minus sign that's in front of the 12 stays there. Next, I'll subtract 12 from both sides, still trying to undo things around the x. And finally, I'll divide both sides by 2. So the answer is x equals negative 12. Here's just a few more. In this problem, there are 2 sets of parentheses on the left, so I'll distribute both. 5w plus 15 plus a 3w plus 3. There's more than one w on the left-hand side. So I'm going to combine those together. I don't want to use opposites because they're on the same side. So it's just like combining like terms. In addition, I can put the numbers together. 15 and 3 can be added. So all together on the left, I have 8 w's plus the number 18. Subtract 18 from both sides. And finally divide by 8. So W in this problem equals negative 4/8, or negative 1/2. This last example also has two sets of parentheses. I'll distribute the 6 and then distribute the negative 2. Negative 2 times negative 4 is positive 8. Just like the last example, there's two sets of x's and then a set of numbers. I want to go ahead and combine both. They're on the same side, so I'm not going to make them opposite, just combine them together. All together, I have 8 x's in total, and then a negative 34. Now to undo. Add 34 to both sides. And then divide by 8. Since 47 isn't divisible by 8, I'll just leave it as a fraction, 47/8. The last type of example we're going to look at are equations that are fractions. The most important thing to think about is how we want to get rid of fractions from the very beginning. So instead of getting common denominators and working with them, I'm going to try to find a common denominator and get rid of the fraction. In this first one, we have denominators of 2, 3, and 6. The common denominator here is 6. So a technique we can do is to actually multiply each fraction by 6. If you do it correctly, those fractions should disappear in the next step. So I'll multiply the first fraction by 6, second fraction by 6, and the last fraction by 6. There should be some reducing. For example, here the 6's actually cancel. On the first fraction, 2 goes into 6 3 times. And in the second fraction, 3 goes into 6 twice. If we did this correctly, every fraction should disappear. And you see that it does. This 2's gone, 3 is gone, and so is the 6. I'm only left with the numerators. 3 times 1x is 3x. 2 times 2 is 4. 1 times 5 is 5. It's taken this really difficult equation with fractions and turned it into something that's just a two-step equation. Where the answer is 1/3. Let's look at the next one. Try to find the least common denominator first. I have 6, 4, and 8. The smallest number that all three of them will divide evenly into is 24. So I'm going to multiply each one of these fractions by 24. If we did this correctly, I should get some cancellation for all of the denominators. 6 goes into 24 4 times. 4 into 24 6 times. and 8 into 24 3 times. You can see why you'd want to really keep your work organized with these. All right, going back for the multiplication, I have this 4 times a 5x, or 20x. Next, I have a 6 times a 1, or 6. And finally, a 3 times a 3, or 9. Once again, it turns into a quick two-step equation. Where x is equal to 15/20, or in reduced form, 3/4. Now let's try some that are a little bit more complex. The technique will be the same, just the algebra gets a little bit more difficult because of the number of steps. In this one, the common denominator of 2, 5, and 10 is 10. That means I'm going to multiply each one of these fractions by 10. Just like before, some cancellations should occur. 10 goes into 2 5 times. 5 goes into 10 twice. And 10 goes into 10 once. All right, I'll multiply it out now. 5 times x plus 3 needs to be written like this, with parentheses. 2 times x plus 4 will also need parentheses. And finally, 1 times 3 is just 3. We'll have to use the practice we did just minutes ago with the distributive property. I'm going to distribute the 5 and the 2. So I have 5x plus 15 plus 2x plus 8 equals 3. There's some common terms, a 5x and a 2x that I can put together, as well as some numbers, 15 and 8. They're all on the same side, so they can be combined to be 7x's plus 23. Now it's a two-step equation. X equals negative 27ths. Let's try another one of those complex equations just for practice. See if you can find the common denominator. Did you think of one for 4, 6, and 3? Should be 12. Stop the video and try the next step yourself. Right, let's see how you did. 4 goes into 12 3 times. 12 goes into 6 twice. And 3 goes into 12 4 times. So when you write it out, we'll have 3 parentheses x minus 1 minus 2 parentheses x minus 2 equals 4 times the 2, or 8. More distributing. Try the distributing part yourself. You should have gotten 3x minus 3 minus 2x plus 4 equals 8. Check this sign right here. Should be a plus. By combining together like terms, the 3x and the negative 2x, and the numbers negative 3 and 4, this should break down into a two-step equation, or maybe even a one-step. All I have to do is subtract 1 from both sides and I have the answer. X equals 7. Go ahead and try the exercises that go along with this section now.